Hey everyone, today I'd like to walk you through a case study on how we're using artificial intelligence to extract geochemical analyses from over 500,000 rock samples described across thousands of mining exploration reports. You know those PDFs that sometimes stretch beyond 2,000 pages and feel like they were written by a rock rather than by an easy-to-read geologist? I'm Henry, and I work at Agile Data Decisions as the Chief of Customer Success. Our startup is basically trying to teach AI engines to read technical docs as a domain expert. Our AI platform is used in the energy, mining, construction, defense, and health sector. So if your job involves digging holes, building stuffs, save human lives, or if you are engaged in the defense of your country, we've probably got something for you. This presentation has been prepared with the support of the Ministry of Natural Resources and Forests of the province of Quebec in Canada. I would like to thank them warmly for that. Now let's start. Since ChatGPT burst onto the scene in 2022, I'm guessing most of you have become pretty cozy with large language models. You've probably spent hours crafting the perfect prompt and crossing your fingers for a miracle reply, or at least something correct. Some of you have even tried using these digital genies to capture data, information, or knowledge from existing mining exploration reports, which, let's be honest, are not exactly beach reads, even for an AI. Here we are on page 233 of an assessment report done on the Piqua property in the James Bay area, north of Quebec in 2018. The page 233 describes some of the collected samples and provide their coordinates. Let's ask a question using our chatbot based on ChatGPT about the first sample. What are the coordinates, easting and northing, of the sample L256607? Awesome. The reply is correct. Fantastic. And now let's ask the same question about a sample at the bottom of the page, just here. But look at the reply. The reply is wrong. This damned AI is not able to provide easting and northing coordinates for this sample. Data scientists could explain why it is super difficult for a semantic model, such as an LLM, to detect numerical values in the middle or at the bottom of a table. But whatever the explanations, you can understand that the experiment we have just done together is super annoying when your task is to populate a GIS system like the Quebec Sigiom with the geolocalized assay information of millions of rock samples described in thousands of assessment reports. You were counting on the magic and the speed of the generative AI, and you learned that AI may make errors and miss data. Will the GIS remain a trustworthy tool if the AI injects erroneous data points or misses 50% of them? I guess not. In the case of the public GIS portal of the Ministry of Natural Resources and Forests of Quebec, accuracy and completeness are crucial for end users and for the credibility of the organization. So, how can millions of data points be captured exhaustively and precisely from thousands of assessment reports? What are the options we have? Forgot about a deterministic process based on rules because of the variety of formats used in exploration reports through time? It will never work. What about a manual process with dozens of data clerks? This could provide a precise set of captured data points, but time and budget will be prohibitive. AI can process thousands of documents and capture the information in a few hours, but today, AI cannot provide the needed level of exhaustivity and precision for the requested task. So what? Should we discard AI because it is not trustworthy enough? Should we discard the human process because it is too costly? Why not think about a process based on the AI productivity and human precision with a touch of deterministic script? Why not an AI process with a human in the loop? We aren't at a point where AI will replace data managers, but we may be at a point where data managers working with AI will replace data managers working without AI. What is key, however, is a platform where humans and AI can work together. Collaboration between machine and data scientists, business experts, and data managers is the background of the human-in-the-loop concept. And to make this collaboration efficient, all you need is an advanced user interface. A UI where the data capture done by the AI agent can be easily checked in their context. A UI where you don't need to be a data scientist and a perfect coder to train and benchmark AI models. And a UI where several users can work together safely following the data governance rules of the organization. The human-in-the-loop approach is at the core of the AgileDD platform design, and our user interface allows a real collaboration between data scientists, subject matter experts, and AI models. To make possible the data capture from Quebec at the expected level of accuracy, we have implemented the following process in our platform. At first, a set of agents perform a set of tasks such as the OCR of the document, the detection, classification, and segmentation of the tables, and the capture of metadata related to the sample tables and the assay tables. The captures done by the agents are carefully checked by data clerks in context with the UI and eventually edited. Once the data are captured and checked, a deterministic script can structure the captured data into a format which can be easily ingested by the GIS. The script also performs some controls and produces a log which is analyzed by a senior data manager. Finally, a geologist has a look at the produced data and evaluates the data quality before their publication. But more importantly and more fascinating is the possibility of the process to learn from each detected error or validation in a continuous learning process, which increases the accuracy of the produced data with time. This combination of automation with AI and quality control by humans allows a perfect capture of information, even in adverse conditions like faded scans or very small font size. The human-in-the-loop approach also authorizes a high-quality sample table segmentation and a precise recognition of the column headers despite the variety of formats. The same applies to the assay tables. The variety of formats is handled by the process. The handwritten annotations of the tables are no longer an obstacle, and the partially masked tables are processed without error. At the time of formatting the captured and checked information, the deterministic script detects the way the assays with a lot of samples and analyzed elements have been printed on several pages to generate a unique table per assay. And the script is agile enough to match the sample descriptions and the analysis, even in the case of variations in the sample IDs. The final deliverable is a set of very accurate geolocalized analyses. Because the process is based on an AI automation, around 500,000 analyzed samples have been plotted in 1 year. Thanks to the quality control milestones, the produced data points have the same accuracy as the data points captured manually from documents. The productivity monitored over the last 14 months reflects pretty well the advantage of continuous learning. Our platform has been able to process with a high level of accuracy 3,000 plus pages in the first month. No delay is observed between the start of the process and the first deliverables because a first version of the models can be trained very rapidly. Over the first 6 months, the models have been improved by continuous learning thanks to the feedback of the production team. As the models improve, the number of errors decreases, allowing the production teams to reach 16,000 pages a month, hence around 50,000 analyzed and geolocalized samples a month, plus around the same amount of analyzed samples without coordinates and approximately 20,000 described samples with coordinates but without analysis. The human-in-the-loop approach has long been a cornerstone of responsible and effective AI deployment. Today, at the age of generative AI and agentic AI, its core advantages remain highly relevant, though they're evolving in interesting ways. Accuracy and reliability. Humans catch edge cases, anomalies, and errors that models may miss. They validate outputs, especially in a high-stakes domain like geoscience. Accountability. HITL ensures that decisions reflect human values and reasoning. It provides an audit trail for compliance. Transparency and explainability. The HITL approach is crucial for trust, especially when models are complex. Risk mitigation. HITL acts as a safeguard against automation error and unintended consequences. This is very important in systems where probably correct isn't good enough. To wrap up, I hope this presentation has given you a clear view of the challenges we faced, the solutions we implemented, and the impact we've achieved. But more than that, I hope it sparks ideas, questions, and conversations. Because innovation doesn't end with a slide, it begins with dialogue. Thank you for your attention, your curiosity, and your time. I look forward to continuing the discussion.